Okay, so the next thing is now talking about the line that's going to be perpendicular to the tangent line. I'm not really sure about the applications of that, but I'm sure they're out there. But so the normal line then is perpendicular. So once you found the once you found the slope, if you needed to find the slope of the line perpendicular to that, you would just do negative reciprocal. So let's say this. So if the slope of the tangent is equal to a over b, then the slope of the normal or the line perpendicular, I could have put a perpendicular symbol there, would be negative b over a. So you do reciprocal and you change the sign, just like you did with perpendicular lines a long time ago. Okay, so all right, so here's one where we just got a whole bunch of stuff going on. All right, so it says use the limit definition to compute the slope of the tangent line at x equals a. Okay, fine. So that means we're looking for f prime of a, and that is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. All right, so that's just our definition, limit definition of the derivative. So that's the derivative or f prime or the instantaneous rate of change when x is equal to a. And so on this particular case, we've got this fraction thing going on here. All right, so we've got some options. So I'll show you the way I would like to do it, but you do have a couple of different ways you could go about it. So we would have 1 over a plus h plus 3 minus 1 over a plus 3, whole thing divided by h. There you go. Okay, so all right, so what do we want to do? Well, I think we definitely want to do a common denominator thing here, and then this h, because you can think of that as h over 1. That actually, if you did the reciprocal of that, if I did over 1 there and I did the reciprocal, then it would join these two denominators once I've brought them together. All right, let me show you what that looks like. So this would equal the limit as h approaches 0 of, okay, now, so my common denominator would be these two multiplied together, all right, because they have nothing in common, and that's always been the case. Like if that was 5 and that was 6, then you would use 30, same situation. So what happens is then this fraction would become a plus 3. I'd have to multiply top and bottom of it by a plus 3. So I'd have a plus 3 minus, and that's this minus sign right here. So let me go ahead and, that is this minus, there we go. I'd have to multiply top and bottom of this fraction by a plus h plus 3. So that 1 would get multiplied by a plus h plus 3. All right. And then my denominator, of course, would be those two multiplied together. So that would be a plus h plus 3 times a plus 3. Now, here's what I said a minute ago, though. We've lost that h, right? Well, not really, because I was thinking, well, instead of this division, couldn't we just multiply by the reciprocal there, right? But I like to think of it as like anytime there's a denominator of a fraction and it's just a single thing, and the numerator has denominators itself, then that h can join those if you so desire. So that's going to show up right there. All right, but that's a kind of a good way to explain it, but like why that happens. Okay, now just like before, anything that doesn't have an h up top should go away. I mean, you can see it happening, right? So so let me hold on to the limit notation. H approaching 0. Okay, a minus a, gone. I mean, if you want to distribute, we can. I don't mind showing that. You can fast forward if you don't want to see it. You can go to the next step. There you go. But you could think of the subtraction as, you know, at the same time. A minus A gone. 3 minus 3 gone. But I'll show that on the next one. So, and the pain of and so you could really skip this one right here if you like. I just, you know, I just don't want to. I just don't want to. Just like to show as much as possible. Okay. All right. So then we got lots of stuff that's going to happen. I'll show part of it to begin with. So the A's are gone, right? The 3's are gone. I've got this negative H that's staying. All right. So I've got equals the limit as H approaches 0 of negative H. And once again, just like before, now we'll be able to cancel with the H on the bottom and leave us with a negative 1 up top. All right, so then I've got A plus H plus 3. I'm going to run out of room. I don't think that'll, no, it's going to work. It's going to work. A plus 3. Okay, but if you knew what was going to happen, if you knew that that purple or pink or whatever that was going to happen, and then you knew right after that this would happen, then it seems to me you could have gone straight to this step right here. Like after seeing this, I don't know if you needed to write both of those. Those both are showing the cancellation. It seems to me that a logical step would be to go straight to showing those two sets of cancellations, right? So we had a addition and subtraction cancellation in the numerator, and then we had a division right there, okay? So it seems to me you could have gone straight to this and say negative 1 over, and then I keep having to write this A plus H plus 3 times A plus 3. All right, next thing is going to be the answer, because I can go ahead and substitute in. And then, so up top, of course, I've got a negative 1. And the bottom, if I sent H to 0, I would have A plus 3. This would be A plus 3, and that'd be another A plus 3. All right, so that would be A plus 3 squared. Okay. All right. Woo-wee. All right. So done with that one. So now I bet you anything, it's going to ask us to find the slope of the curve when x is negative 1. So what we're doing then is we're trying to find the derivative, make sure I'm saying that, because that's what this is all about, the derivative, or f prime, of negative 1. So I'm just going to substitute negative 1 in. That was a whole lot of work. And once again, there's going to be a shortcut for that. All right. There is. And by all means, be angry. All right. So then I've got negative 1 plus 3 squared. All right. So that's going to be negative 1 over 2 squared. So the slope on that curve, that particular curve, that 1 over x plus 3, when x is negative 1, is negative 1/4. Let's see if that makes sense from the graph. Negative 1/4 should be a downward slope of just a fraction. So here with Desmos, 1 over x plus 3. So I need 1 over x plus 3. And at negative 1, we're right here. Yeah. All right, that looks pretty good. And so at that moment, that line right there, that tangent line, indeed, has a negative slope. It's definitely fractional, definitely less than 1. And so negative 1/4 does make sense. All right. Well, what's next? Okay, write the equation. All right. Well, they didn't tell me this time what the y value was, so we'll have to go back and find out. And that's no big deal. So when I'll just so here's what I need. I already know the slope. I know f prime of negative 1. That's great. But then I also need to know the x and the y. So in other words, I not only need to know my slope, which is f prime of negative 1, I also need to know my y, because that's part of the equation for the line. I need to know y1, actually. So y1 would be f of negative 1. Okay, so so this time they didn't tell us. Like on the last problem we did where we did this, they told us 3, 9. 3, 9 was the point. And they could have said, x, if x is -1, then the y is 1/2, right? It's because I'm going 1. This is the original equation. The original equation they told me. So -1 plus 3, which is 1/2. Now watch this. And so now that I know x, I know y, I know slope, I can write the equation of the tangent line. So y minus y1, nothing wrong with leaving it just like that, equals your slope, which was -1/4. We found that out by doing the work on, well, a and b both, right? A and b both led us to it. So -1/4, and then x minus -1, right? Which is x plus 1. And there is nothing at all wrong with leaving it just like that. Now, the only thing that might happen, of course, is it could be a multiple choice question. So if it is, then they're going to distribute and then add the 1/2, right? So just as a little side note here, it could actually be y equals -1/4 x, just in case they did a multiple choice. Because I don't know if they would leave it. They might leave it like that in multiple choice, but you never know. So distributing there is going to be -1/4. -1/4 plus 1/2 is a positive 1/4. So this would be the equation of the line in slope-intercept form. But this point slope is great. And then Gene, of course, will have that 1/2 added to the other side. I like the consistency of subtracting both times. The y minus y1 equals the slope, and then x minus x1. I like that, but you can do whatever you want. All right, now watch this. This is going to be super quick. All right, so the slope of the normal or the perpendicular at the same place. So the slope of the perpendicular, I'll use that symbol this time, is going to be the negative reciprocal slope. Well, the slope was -1/4. So if I flip that upside down and change the sign, it's just +4. Those two should always multiply together to give you -1. That's another thing that a lot of people say. The slope of a line and a slope of the line perpendicular, they multiply together to give you -1. But a lot of people, and a lot of your teachers probably have said, they're just negative reciprocals, all right, which technically, I guess, is not technically correct, but it does tell you what they are. All right. So then the equation of the line, it still goes through the same point. So it's still going to be the y minus 1/2. Right. It's just the slope's changing. All right. So this line then is going to be 4 and then x plus 1. I want to draw these like on Desmos. All right. So, and just to show that it works. All right. So get out of there, get here. So y equals -1/4 x. All right. Already forgotten. Y minus 1/2. Oh my gosh. Okay. So y minus 1/2. Good. And then x plus 1. Ooh, look at there. And then I love Desmos because it shows like intercepts and then intersections, right? So we got that little intersection right there at -1, 1/2, just like we expected. All right, and then the one that the normal, the perpendicular, then was still y minus 1/2, but the slope became 4. All right, so and then it's still through x plus 1. And there we go. And so, and once again, we still have that intersection. That's great. And then a little x-intercept there and a y-intercept there, which we don't really care about. We just cared about the equation of those two lines. And so, so there we go. So that's the one that we're going to be talking about mostly. And occasionally they ask for that normal. And again, applications, I've never bothered to look up what they may be. But I do know for the tangent line, yeah, all kinds. All right. Where's that put us? Ah, good. Okay, so now this is very popular on the AP exam. It says use the equation in C to estimate the value of, this is worded wrong, estimate the value of f of -1.1. Listen, she made how many pages here? Of a ton of pages. There's going to be a mistake here and there. Are you kidding? So that is not criticism. All right. So estimate the value of f of -1.1. So So what it's saying is we want to, let me go back to Desmos here, not this one. That was the normal. So you go away. All right, this, I want to use the green line to approximate the blue curve. Well, that works pretty good when you're close to the point of tangency, but it doesn't do so good as you move on down, right? The green line's not going to do a good job of approximating the blue curve whenever it's down here. But when everything's really close here, and she said negative 1.1, man, that's great. I mean, negative 1.1, I can barely even tell that there's a difference between the curve and the line. So the line does a good job of approximating. All right. So what it's saying is take the equation of the tangent line and substitute a negative 1.1 in and use that as an approximation for the function itself. Okay. And you're like, well, couldn't I just substitute into the equation they gave? Yeah. But this is going to be what you're going to be asked a lot. Find the equation of a tangent line, use that tangent line to approximate the value of the curve. Okay. So in other words, I'm doing this. So I'm going here and I'm going to say, and I guess from the, I don't know. I'll do it from here. So all right, let me say this. F of negative 1.1 right, would be approximately the same as substituting into this. And I'll go ahead and add the 1/2 to both sides. So approximately equal to 1 negative 1/4, and then a negative 1.1 substituted into the line that we created. Okay, and then I have to add the 1/2. Okay, I like that. That's pretty good. All right, so then we just have to clean this up on the right-hand side. All right, so this is negative 1/4. And then this right here is going to be negative 1/10, right? Just to kind of keep our fractions. Yes, negative 0.1, right? And then plus 1/2. So we don't want to blend the fractions and the decimals too much. Okay, and so then this is 1/40th, right? Yeah, 1/40th plus 20/40ths, 1/2. Ah, gotcha. I said something and wrote something else. Oh boy, that's some problems right there. All right, and then so 21/40ths. So 21/40ths would be a good approximation for the curve when x is negative 1.1. It's not exactly what it is, but we're using that line to approximate the curve. Okay. All right. That's it for example, whatever this is, 6. Yeah, example 6.